let's start with presentations. I have Ulf. I think you are with us, Ulf. Let me present you. Ulf Wiger is. Hi, Ulf. Ulf is an Eternity core developer for us. He's a senior specialist in architecture and design carrier class systems. He had a rare opportunity to influence world-class products from conception through release during several years of features upgrades and maintenance. And finally, a significant technology shift. His previous experience includes architecture and design of decision support technology for the US DoD and the Alaska Integrated Incident Management System. Serious stuff. He worked in both small startups and large corporations, and he has a very special interest trying to bridge the cultures of research, open source development, and industrial design. Ulf is going to be presenting an introduction to state channels, implementing soft real-time use cases an option, and how to go about it. So he's going to say the real way what I was trying to explain with some weird example. So thank you, Ulf. We will play your presentation, and then we will go to the questions.
Good afternoon. I thought I'd introduce you to some of the design ideas that went into Eternity state channels, and why we think they are especially suitable for real-world use. The Eternity blockchain was always intended to be the best blockchain we could build in an overall practical sense. This was also true for the state channel design. We wanted to build something that would actually be used and hopefully enable some new exciting markets and use cases. While this might seem obvious, there will always be situations where your motivations are put to the test, where you have to prioritize between different, possibly conflicting design goals. I'll try to give some examples of this. As much as we all love blockchains, compared to most applications we're used to, they offer a pretty horrible user experience, with pathetically low throughput, long response times, and weird new complexity that we have to wrap our brains around. While state channels promise to offer much greater throughput and, most of the time, immediate confirmation, they are no less complex and can be very hard to get into. This may help to explain why, after having been a promising technology for about 4 years, there are still very few practical applications around. For Eternity state channels, we wanted to keep things simple, certainly from the beginning. We decided to first build one-to-one channels with a straightforward protocol and dispute rules. We also wanted the client API to feel as simple as possible. Much for that reason, we decided to put a lot of effort into designing a proxy agent that took care of most of the tricky parts. We call it the FSM. FSM is short for finite state machine. That's what happens when you let programmers make up names. So the architecture looks something like this. The client connects via WebSocket to an Eternity node where an FSM process is created. The FSMs of the two participants find each other through prearranged means. They don't have to reside on the same node. And they set up an encrypted communication channel. The encryption used is called noise. In the node, there is also a chain watcher, which helps the FSMs keep up with what's happening on the chain, and a state cache for maintaining a backup copy of the off-chain state. If the FSM dies, the state machine persists a copy of the state encrypted using a random key. Now, if you would try to describe the most generic type of state channels, it would look something like this. They will all set things up using a mutually signed on-chain transaction. After that, the channel state can evolve through mutually signed off-chain updates. In the happy case, the parties then mutually sign a channel close transaction, releasing the funds deposited in the channel. In the less happy case, one participant can singly sign a unilateral close transaction, which is then followed by a dispute period where the other party has a chance to challenge, for example, with a later mutually signed state. This seems straightforward enough, but usually one wants more, and this is where it gets a little tricky. One way forward is to work on the theoretical model, trying to find the most scalable, most theoretically coherent model. Another way would be to find pragmatic workarounds for problems not yet fully resolved theoretically. Now, while these paths should ideally cross-pollinate and eventually converge, they may look quite different along the way. Specifically, the effort that goes into going that extra mile for real-world users is usually poorly rewarded if you're in a research project. Lots of grueling work and very little to publish in the end. One issue that comes up is that while channels are fast once set up, the initial setup takes place on the chain, and so it's subject to the usual confirmation time. With Eternity's Bitcoin NG style consensus, you could minimally wait until you see the transaction in a microblock. This doesn't guarantee that it will ultimately stay on the chain, but at least some miner thought that it was worthy of inclusion. In real-world applications, things are complicated by the fact that mobile apps don't want to stay active for minutes waiting for something to happen. And as soon as they go to sleep, chances are the WebSocket connection will fail. We spent considerable effort ensuring that the client can disconnect as soon as possible. That would be as soon as it has signed the create transaction, and then reconnect later to resume work once the channel is active and confirmed on chain. Long-term, virtual state channels would provide near immediate confirmation. Another issue familiar to blockchain users is the problem of conflicting updates. It comes with a territory of no trust that there is no good way to coordinate updates. Practically all such algorithms are trustful. One can address this in different ways. One way would be to employ so-called Byzantine protocols or eventual consistency, which would theoretically allow for a higher degree of parallelism. But that's not without cost. Application designers will have a harder time making even fairly straightforward use cases work. So at Eternity, we decided to go with a simple conflict detection mode, assuming that most update patterns used will be fairly safe by design. And so reporting to the clients whenever they are talking past each other should actually work pretty well. We introduced generic messages to allow applications to overlay a coordination protocol or resolution protocol of their choice if needed. Now, generic messages are useful in other ways. Many state channel users will want higher throughput than the perhaps 10 to 100 transactions per second in a single channel that are feasible with mutually signed volleys. Again, there is a choice. You can try for limited mini updates, singly signed updates with veto rights, that come with a dispute time, for example. This will complicate the application model. We decided to go with a more traditional layered solution. So at the lowest level, you have the on-chain transactions, which are very slow, but essentially your ultimate source of truth. The mutually signed off-chain transactions are semi-fast, but still offer good security in a trustless setting. Generic messages are unsigned, free-form, and very fast. Say, 1,000 messages per second in a single channel. We feel that this allows for speedy interaction combined with trustless exchange and solid conflict resolution. You just need to think through where the heavier tools are called for in your design. Ultimately, for people to get on board with state channels, your API needs to be intuitive and allow for productive development. We decided to design to the limitations of JavaScript and app development, not least trying to keep as much state machine complexity as possible away from the client and contained within the FSM, which is written in Erlang, which is perfect for such things. For backend applications, we have an Elixir-based component, which we recommend you look into. But the WebSocket API, using JSON RPC, tries to make things as easy as possible for the developer. For example, passing info reports with the state and status of the channel, and providing diagnostic functions where you can fetch the off-chain state, message history, etc. We think that a common use case for state channels will be where one side runs server-side logic. To simplify this case, we made sure that an application can allocate one listen port for all clients to connect to. On the server side, the same responder pub key is used for each instance on that listen port, but for each listener, the initiator can either be set to any or a specific pub key. The latter case would be used if the responder is waiting for an already established session to be re-established. And again, on the topic of failing WebSocket connections, there may be times when connectivity is so poor that it's hard to stay connected during the session. Imagine that you lose connectivity while waiting for your turn in the coffee shop. We decided to allow update requests to be already cosigned, in which case they can be served even if the client is offline, assuming that its FSM is still up and running. This out-of-band signing might, for example, be done by scanning a QR code. Now, one thing that we discovered ourselves while writing test suites was that manually crafting dispute messages for the chain is no picnic. Also, keeping up with the chain, detecting malicious transactions, trying to subvert the channel, as well as dealing with so-called time travel if the chain should fork and, say, various transactions evicted. These are all mind-bendingly difficult things for any developer. The FSM takes care of these things and informs the clients of events on chain, as well as, for example, if a challenge is called for. The client can then request, for example, a slash, which is a form of challenge, in which case the FSM will generate an appropriate transaction for the client to sign and then post it on chain. As much as possible, the FSM tries to help the client identify the tricky cases and suggest ways to get through them with reasonable effort. So, these were some examples of how we try hard to make Eternity state channels commercially usable, with strategies for dealing with the harder aspects of state channels. With a coin toss demo, we hope that you will be able to see some of these things in action and be able to build on them. We'll be happy to answer any questions you might have. Thank you very much.
Thank you all for your presentation. Are you there? You want to come?
I am.
Up to the stage? Great. So let's see. We have a couple of questions here on the chat. We have one that says, where does Ulf see A-state channels in the global blockchain picture of state channels, implementations, functionality, maturity?
Okay, and in terms of state channels, I mean, not just, of course, you have Lightning, which I guess needs to be seen as a mature implementation. I'm not aware of any really solid commercially solid implementations. We have had some interactions with the Ethereum-based state channel projects. While they are working very hard trying to improve sort of the theory behind state channels, and I would say their focus right now is to merge their theoretical models to come up with sort of a common language and a common platform for further research. So I think that's all good. If you consider their focus, but if you look at state channels that make a claim to be sort of commercially usable, I guess you have Eternity and you have Stellar Networks. Stellar Networks just a few days ago announced an upgrade of their mainnet. Well, it seems like it's starting to get real, but they're also moving very slowly to try to shake out bugs, and so we'll see how that goes. I think there is definitely place for or room for both them and us, and there is a vast field of implementations, I'm sure, or applications for state channels. So I think right now what we want to focus on is really building a good platform where you can get started quickly and start being productive, building applications. And I think if we have a good chance of cornering a fair bit of the market, I would say. And I think that in terms of robustness and usability of the APIs and everything, we're in pretty good shape. I'd say it's the UI, the client-side wallet. Those are areas where we've been a bit slow to come up with useful components. This, I think, is changing very rapidly now.
Awesome. Well, it seems like we are some step ahead, so that's great. That's great. We have one question from Vishwas. Can clients reconnect to a channel from different nodes which they never been connected to earlier?
So if the question is, can you start a channel on one node and then reconnect to another? Currently, that is not possible. It probably wouldn't be terribly difficult to implement, but it hasn't been a priority, so we haven't done that yet. We've been discussing it, so we have a fair idea of how to do it. If it's just basically, can you connect to a node and set up a channel, then yes, if the maintainer of the node allows you to, in terms of their socket setups or whatever, the node doesn't really, the Eternity node doesn't worry about access control in that sense. That's up to whoever runs the node.
We see what we just think. On the meantime, we have another one. We have one from Milen. Could the FSM be decoupled from the node, and will this allow more usable, flexible channels, also more maintainable?
So, well, in the sense that we have the internal protocol, the messaging protocol between the FSMs is documented, and there is a well-defined serialization. So we've wanted to make sure that, and also the on-chain interaction is well documented. So we didn't want to lock ourselves into needing to have an FSM at all. Whether it could be decoupled in practice, the main challenge would be that if you're not actually running a node, at least you would want to subscribe to chain events from a node so that you will know or detect quickly if the other side is trying to subvert your channel by posting channel transactions on the chain, because then you will have to realize that and respond. So we have thought about building some kind of chain proxy that actually sort of provides the FSM with the necessary information from the chain, so you don't have to run a full node. That would be interesting, for example, if you wanted to run on like a mobile device that doesn't have the storage needed to run the entire node or the entire chain. So yeah, we've done some experiments and had some discussions on that. So if someone wants to pick up that thread and sponsor it or start working on it, we can certainly help with some ideas and advice.
Awesome. Now that you mentioned the mobile phones, I have one question from Marco, and we are many are interested in knowing this. What do you think is going to be necessary to get state channel reusable on mobile phones? Is there something missing right now, or do we have already all the tools in place?
So the thing I mentioned about the storage capacity needed to run a full node, that would obviously be a limitation. There's this slight issue of running Erlang on a mobile phone. We did run at least a proof of concept where we used Termux and were able to compile and at least to some extent start up the Eternity software on an Android phone. I think the more solid way forward would be to use WebAssembly. There is actually a project to try to make Erlang runnable on top of WebAssembly. So whether that would be the way to go, or whether to build some kind of a lightweight client and then implement FSM functionality in some nice mobile device language, I don't know, say Kotlin perhaps. I don't know. It would be a lot of work, but on the other hand, there is a reference implementation to look at where a lot of tricky issues have been solved. So that makes it a lot easier to do a second implementation.
Okay, great. Thank you for that. Let's see if we have other questions. By the way, you need to think a couple of very tough questions from Nikita is doing some comments on the chat.
Okay.
Let's see what we have here. Those usable, we have one from the Botanical Carebot. Does usable node also means just using a hosted node?
Usable not. I was referring to usable in the sense of actually being able to build commercial applications and not get blindsided by having the maintainers of your platform not really have a commercial focus or whatever. So usable in that sense. If I'm an application developer, I don't want things to just look promising. I want them to actually work when I start building on them.
Okay, very well. I think we are set for now. Thank you very much, Ulf, once again. And please stay with us for the rest of the presentation.